Hello, we are back live. Hi. I am late today once again. With good reason for the most part. I actually got up pretty early this morning. I started working on a new article for you all. I think it's one that people will really like, but it's going to take quite a bit more work. I literally just wrote the intro sections today. Hopefully that'll be out within the next couple of weeks. See. So what are we going to do today? Today, first of all, we have this nice sweep result where we've solved 2048 pretty well, apparently. But what we're going to do today is we're going to work on the drone sim for a bit. That's like the main plan. Specifically, I think we're just going to formulate the drone objective as go to point and don't collide. And like most things will be some combination of go to point and don't collide for this sim specifically. Take a quick look at the current thing. This is what we have, right? Got a model. Gotta mess with these reward functions. So most of these are not that bad. I think the only thing that really needs to change is the orbit one. Probably the orbit one. So I need to generate points on a sphere. What's a good number of points? 8. Be many, I think. Like 4. What's the easiest way to do this? So I want to generate points on a sphere. This is going to be some obnoxious function, actually, isn't it? I don't know. Let's do generate. This is the type of thing, though, that's done very quickly in a shader. See if I can get a reasonable function. Okay, so you get the Cartesian coordinates from the conversion to spherical. I don't know why you do it angular, but sure. We have M rings. That's like super obnoxious, isn't it? Should be able to do it as a pure function of time. Oh yeah, I forgot that I posted the trailer to YouTube. Of the Neural MMO channel. We have this one, which is posted. Why is it CC'd?
Welcome to the boot
Oh,
camp.
that's closed captions. Okay, so they both have, I don't know, some small number of views.
Well,
the guys I'm on, these posted, I forget what, 12, okay, 13 hours ago. Cool. Trailers are up. Yeah, I think regardless of how I do this, it's going to be annoying. So we'll just start on it. I really don't like this type of, well, to be fair, as long as I get it, I can verify that this is correct separately, I guess. And then I can do the RL. So normally I'm very adverse to doing anything remotely janky, because then RL makes it way worse. Thanks for sending over some drone kit. Of course, Finn. Have you gotten any more of it? They should all be there somewhat soon. Heck yeah, man. I'm still working on the drone stuff. I realized that we can do a lot of demos just as a function of like go to position, but with just like different versions of that basically. So I'm working on that right now. kind of need the index, don't you? Super annoying. Works. Well, let's just say for now, I'm going to do it's so incredibly jank. 0 and omega r. Radius. Sine. Okay, so that's spherical to Cartesian. Maybe something like this is not terrible. All we have to do is set a per drone target, right? So we just do move this to here. You know, this is actually not going to be bad. I could use a little bit of just chill work like this for a bit. The only mildly annoying thing is the sphere math. I think if we're clever here, it can probably come up with a whole bunch of cool demos just based on this one simple thing. Okay, so in reset, this needs to move up to here. Now all the agents have different targets. We can do update target. Now this is actually going to be the same exact thing as before, just way easier. Right? Okay, solid. What are you using for that autocomplete? Oh, is this just now? Okay, so for idle targets, you can probably do like, where's the sphere velocity thing? This thing, right? I don't think how we're gonna synchronize this for everything. Do we do it based on the initial? Hope it doesn't diverge. No, I don't like that. Leave it like this for now. Oh yeah, it's for a bit. So yeah, this works. This here works. And what else did we have? We had follow. This was the one that I didn't know how to do cleanly. This is technically like a move target, I guess. Right? This can be move target. And then this one can be this is going to collapse them all to one target for now. Okay. Now we have something like this. Have to do word. Going to be distance reward. This gives us position target. Yeah, not this at all though. Well, I wish I could disable multi-line. And then what was the reward I came up with? Yeah, negative. So we just do reward plus float. Negative distance over max distance. So your distance reward times density. I believe this is going to be 1 minus. Okay, cool. So compute reward. Now all this doesn't need dex anymore, so that's cool. Hey, Major. Daily grind continues as per usual. Speaking of which, we have the daily grind of fly killing, because I had some maintenance work and I see 3 flies that I may as well just kill now while that's easy to do so. One. -3. -4. I actually have thought about doing an RL trained laser turret in moments of frustration. Seems like a lot of work, and I don't think I'd be able to actually sell them for any reasonable amount of money. You'd probably just get sued for blinding people with them. That's my guess. I would very much like to just zap the damn things, though. Yeah, I've been working on, one of the things I've been working on here is trying to figure out how we can just reduce the number of stuff that gets in. It is a farm, and lots of just bugs and things get in. And man, it's like, you think, oh yeah, it's no big deal. You deal with a bug once in a while. But the thing is, when you have stuff that like lands on you once in a while, right? And you look and oh shoot, it's a bug. Like every single time something slightly itches, you will think, oh, it's a bug, and it will drive you insane. Incredibly annoying, yeah. And actually, it's so buggy outside, I stopped running outside. Well, first of all, it's stupid hot here, and I'm going to be in California in a few weeks. So I'll be able to run there anyways, but other than that, like, literally I went for a run for, I think, an hour and 5 minutes, and I had, like, 4 or 5 golf ball-sized welts on my back by the end of it, from just, like, big horseflies just taking chunks out of me. You literally, like, rip like a horsefly off of you just mid-run. It's horrible. So I've been... Can you even see that here? Yeah, you can probably see in the background. I got the bike and I've got the erg. I think you should make some from scratch tutorial videos for some new M's, integrating them, designing reward terminal conditions, adjusting parameters, bugs, and scooping hyperparams, because the articles are cool, but videos are always better and more appreciated. I'm actually going to take that quote, I'm going to put it into the article that I'm working on at the bottom right here, so I remember this. So here's the issue with the videos, right? Making good video tutorials takes an utterly stupid amount of time. Like, a truly ludicrous amount of time. Like the iceberg video that I published. So I would want to publish something, at least, if I'm going to release videos, right? I'd want to release something that's as high quality as my iceberg video. this took me 2 weeks of work.
Language model.
This is like the highest quality thing I could put out. All right, I put the tux on, I did all this editing. I probably could have made the editing better if I just hired an editor instead of doing it myself. We'll do that in the future. But, I could have spent, it would probably cost me, a few $1,000s at least to get a competent editor for something this length. And this thing got, over the last several months, 3,500 views. That's, simply not worth it. The articles, on the other hand, occasionally, they take a lot less time, first of all, and they occasionally do quite well. So this one that I wrote here, right, this has gotten 100K views. This is actually, this is a worthwhile investment of my time to do stuff like this. I am actually working on a much more detailed article, though. Much more detailed article. You'll get this in maybe a few weeks. That one will take quite a bit longer to write, but nowhere near as long as it would take to make a video. A lot of value. He's doing it for game dev, but a lot of, yeah, it's just if people were actually using them, I would do it. But I can't justify taking 2 weeks to make a tutorial of that form for people to not watch it when I also have a business to build. And I'm doing this double time basically as is. Not always double time, not consistent, but very often working double time. I pretty much work double time until I burn myself out, and then I work normal hours for a week or two, and then I do it again. See, the thing is, I literally did stuff like that before as well. The thing. When I did, Puffer 1.0, if you check on the YouTube, I did, a seminar, I did, here. This is, a full walkthrough of the library. Nobody saw this. I tried a few different experiments, and it just didn't catch on at all. Really, the thing that has been best on YouTube has just been the consistent, people getting involved from the live streams. And this was on a channel that's already had, a couple thousand subscribers on it as well. Because my thesis defense video did very, very well. But the YouTube algorithm is super, super fiddly. And it's just, so uncertain if, technical content like this actually gets seen. So it's pretty rough. It's pretty rough overall. I also don't enjoy it at all. Producing videos is, horrendously mind-numbing, time-consuming, boring work as well. So I basically have to torture myself for a few weeks to make a video, a long-form video like that. So I know how we can do this. I know how we can do it. How about running streams and clipping them and pushing them? Always general purpose and mostly mixed. Recreational programming way. I might run some sort of tutorial on it. I might run some sort of tutorial. You do realize, like, for that type of content, it's not as easy as, like, I just turn the stream on and, like, do a thing for 30 minutes and then clip, like, the quality of that is going to be, like, way, way, way lower versus something prepared. That's super annoying. There will be some more educational content, though. There will be. I have to figure out how to space it out and, like, where to allocate the effort. Because, you know, my main thing is not educational content. It's kind of just been, like, a recent thing that, Puffer has become so, like, relatively so much easier to use than everything else in RL that we're getting, like, lots of new people, which is awesome. And many of them have actually gone on to be productive contributors to the research. It does require me to rethink a few things as to how they're framed, because, like, when I started Pufferlib, the initial audience was RL PhDs, and then it went down to, like, you know, ML PhDs, all right, and then it went down to, like, AI engineers, and now we're at the point where we have literally brand new programmers doing this stuff. It's like, ah, crap. Okay, I didn't position this for I didn't position this for that at all. So I have to figure out how to do that. Implementation of N for X. Improving rewards network design. Network. Parts. So, like, I can do that, right? But here's the thing. Here's the thing that's just jank about that, right? If I did that as a prepared video, I could do that entire thing in, like, a 1 hour lecture. And, like, live with all the demos, I could do that whole thing in, like, a really good 1 hour lecture. It would take me, like, probably close to a month to make that video. If I do it as a series of live streams, it's going to be like, it's not going to give you thorough coverage because, like, you're not going to see all those different things in the context of several different examples. And it's going to be like, many hours. And people don't watch many hour videos, turns out. I have been trying to clip some of the educational like tips and things, and start uploading like short little clips. It's a little tricky to do, but I've been trying to figure that out, how to do it more efficiently. Like, really, the main jam around here is improving the research. I have to figure out how to still make that the focus, right? Okay, so this math did not math. Like, this is cool. This is a good algorithm. How the heck does this work? Some sort of like series? Fibonacci numbers? That's weird. Cool. Some people actually watch them. I do. I watch long form stuff too. Very few do. Carpathia stuff, of course. I interned in Feifei's lab. I think in like 2014 or something when he was still a student there. He's a funny guy. Their own videos. Yeah, honestly, probably the best way to motivate me to make tutorials is to make bad tutorials. So we'll see how that goes. Um, let's see how this article that I'm working on goes first, because like this should be a pretty good comprehensive article. I actually grab this stuff, well, as references for like the type of stuff that people are interested in. This. Obviously, that's not going in the article. I'll use that to write stuff based on it. Also, everybody wants more content. Nobody wants to feed the puffer a star. Go star the repo. It's literally free. Takes 5 seconds. Feed the puffer a star. He's hungry. I opened a PR for the drone env. Simple, realistic motor. Okay, I will have to look at that in more detail, Major. I want to finish this thing right now while I still, like, before I run out of steam. I've already done a bunch of stuff this morning. I want to have this environment done today, so we have, like, a standalone second drone environment. And then we're going to probably figure out a way to, like, pull out the drone so that the drone can just be the standalone thing and we can, like, do all the physics tests, including motor lag. I will definitely incorporate that, though, if that is a reasonable thing to model it. Ah, man. I will say I'm very happy about the reason that I started writing this article in the first place is that the last one did very well. So, if you want me to write more articles or you want me to do more of a thing, go post and support the current thing. Because that all helps. The article. This one. The new article is literally just an introduction section. It doesn't have any content in it yet. I might write on it on stream. Either tomorrow or over the next bit of the week. We'll see. When I'm like sick of coding stuff, I'll write on things. We'll share code walkthrough. It's more of a how to learn RL thing in general, so it's gonna point you to a lot of other resources. The code, that seems like stuff that's like more for the docs. Like, it looks like you want, like, an expanded upon version of like, this tutorial or whatever. Expanded version of this tutorial. I probably should add, like, a sweeps thing to this. I could do that. Adding sweeps. Improving rewards. Improving rewards I will talk about in the article. Network design I can probably talk about in the article. Talk about sweeps in general for sure. And like common bugs. The article will direct you on how to like implement things and it will have you build things. but it's not going to directly be like this piece of code read now, this piece of code read this, etc., etc. All right, let me code my sphere. I gotta code my sphere. Otherwise, we won't have drone things done. You're also more than free to ask questions here, Shadow, while I'm working on stuff. That's kind of the point of this stream. I'm RedZep. Ah, okay. You cannot. People cannot possibly expect me to remember when they have different usernames. So if I get confused, just remind me. I have like a bunch of people on here, and then some people have like 3 or 4 different usernames on all the platforms. What are you trying to do? You're trying to confuse me? Ugh, yeah. Curriculum learning IRL. The curriculum learning goal at the moment is to grow the puffer business so I can get back to doing real research. far beyond many frameworks, beat with the simplicity. I mean, that's the goal. It's simpler. It's simpler than everything but CleanRL. CleanRL is still kind of the best for that. But it is like 1,000 times faster. It's not that much more than CleanRL either. Especially some of the recent CleanRL stuff where they like import and use. Like some of the newer CleanRL stuff actually imports garbage from SB3. Like the original CleanRL stuff that Costa built is the best. And like all the newer stuff, it's just nobody does anything like reasonably. It's such a pain. Have you read the quick start guide though, Shadow or Reds? The quick start guide has a lot of good stuff in it. The article I'm working on is going to basically be a very updated version of that. Pretty much all the advice that I give in there is still good. So it's just going to be like a bigger, more updated version of that that covers more stuff. But pretty much by the time, like, if you've built 5 environments, by, like, environment number 5, you're going to be pretty good at this stuff. Segvolt. Ah. Currently training an agent to solve a very complex robotic operation with long horizon. Fortunately using Isaac Lab, SKRL, but we're considering integrating Pufferlib for your model benchmarks. Issue is developing the env and fixing the bugs. It's taking a shit ton of time. Yeah, Isaac will do that. I had to do some stuff with Isaac Gym for a client. It was a pain. I don't know if you've seen in the last few days, we actually have Pufferlib working with ManiScale. I can push some of this stuff if you want. We will have it pushed anyways in a bit. That mostly just works. The only thing is that the defaults that people use in robotics are moderately insane for all their algorithms. So, like, pretty much it's going to take us quite a bit of optimization to make it as fast or faster than the existing stuff in that space, specifically because, like, the combination of insane reward functions and, like, weird model architectures and, like, weird hyperparams combines to be this very locally optimal thing, and you kind of have to re-optimize everything in order to, like, really beat it. And that's just, like, kind of complicated. Like, I have to set up a big sweep basically to do that. So that is in the cards. And I was working on that earlier this week. I kind of just got bored, so I wanted to do some of the drone stuff yesterday and today. They're not better than Isaac Lab. Isaac Gym was just a student work. They're not that better than Isaac Lab. How's the code? Like, some of the packages that we had to work with in Isaac Gym were just awful. And from what I've seen, even like Isaac Sim, they still use the same packages. Like, people like load. Maybe this is humanoid specific, but they have like MotionLib and PoseLib and like all these other just janky, like an old, horribly over abstracted grad student code libraries. So Manny was at least like relatively easier to get stuff set up and working. Isaac Gym is better developed from scratch Isaac Lab. Isaac Gym better developed from scratch Isaac Lab. Finally. Very similar to Manny's skill. Slightly more complex with more trying to or relying on the same. Yeah. So I mean, robotics is an area that I don't really intend to get super deep into quite soon, unless it would take a company being really interested in wanting to work with us to bring our type of tech to robotics. Then I would do it, but like it's not like a short side project level of an effort, right? Like I pretty much have to rip apart the really overly abstracted way that a lot of stuff is done in robotics and distill it down and simplify it and then find all the things making stuff slow and janky, right, that I'm sure are there. It's the same thing I did with the rest of RL. I'd have to bring over to robotics. It would have to be like a company would have to want like a big contract for us to go do that, because otherwise it's a huge time investment that takes me off of a lot of the stuff I'm doing outside of that. Like the main thing I'm doing outside of this stream now is basically looking for like valuable problems in industry to throw this stuff on. Um, both because that's going to like really help us benchmark and test Puffer, but also, that will solve uh, the revenue problem. So that'll like let us grow way more than we are at the moment. Reach out to you in the next 3 months. Would you be up for 12 months guaranteed collaboration? Yeah, I'd have to know more, right? I don't know if you're at a company or a lab or what, because we do some level of free support for laboratories, and then for companies we do paid contracts. The company, yeah. If you guys are interested in something like that, we could definitely do that. And robotics is one of the things that I've looked into that it like, from what I've dealt with, it feels like it should be very doable to bring like the puffer level of advancements over to robotics. It's just like a fair bit more work than I'd want to do as a side project outside of a contract. Yeah. Yeah, we do two things at the moment, right? We do like smaller jobs that are just like support, extended support and features. And then we do larger things that are more like fixed deliverables, like, hey, we want X built, it's worth Y to us. Help us do that. Shadow, can I ask if it's humanoids or if it's more like industrial? Is it like industrial, like ARM-based stuff, or is it humanoids? ARM-based? Okay, that's actually way better. So, like, industrial robotics, if I had to, like, do something in robotics and pick an entry point, that's the type of thing we'd be way more excited about, because I think that's actually going to have way higher impact than humanoids in the long term. Even if in the short term we see, like, super hype, all, like, tons of companies buying humanoids, yada yada, I think that folks will eventually realize that it's, like, woefully impractical to have this one-size-fits-all, but, like, really slow and expensive solution for everything. Um, I personally, I would love to see like industrial robotics, like the arms moving at 5 times the pace that they currently move. Fuck humanoids, yeah, man. It's like I kind of see why there's the appeal to it, but like I don't think humanoid robots gets us to like sci-fi era awesome tech everywhere, you know? That's kind of the way I look at a lot of stuff. Humanoids is like it's faster horses. You're replacing human workers with something that's going to be maybe about as effective as a human worker. Like, eh, exactly what we're doing. Be happy to chat. Long horizon multitask optimized policies. I've actually been thinking about stuff like that and how you solve. So basically, I could solve your long horizon problem pretty much out of the box if your sims were fast enough. That's the key annoyance at the moment. Um, so I've been thinking of like if there's a way to do like super low fidelity, very domain randomized, and then like fine tune up to faster or like to slower, higher precision. There are a lot of knobs that need to be messed with. The Sims are just really slow right now. I think that's the main annoyance. It really doesn't feel to me like from first principles either that like if you can run a humanoid at 10,000 steps per second state based, you can only run an arm at like 40,000 steps per second with the same settings. It seems like just like a 6 degree of freedom arm. It seems to me like you should be able to run it at least in like hundreds of thousands with reasonable fidelity. And like current Sims just aren't doing it. I could be wrong, but just like based on what I know about the problem, given that they're not even doing like gel sensors or anything like that, stuff should be a lot faster than it is. like, oh, it's built on physics and physics is fast, therefore our thing must be fast is not really it. You know? We're just two AI engineers and a T plus years of RL experience. Once we have a simple bug-free env, get to the level of first real robot deployment, I'm gonna call you. Sounds good. Yeah, man, good luck with that. Robotics is hot at the moment, but it's also it's a tough problem in the sense that like all the sims and tools are really big and bloated. This is kind of the problem I had to solve with RL in general, right? Like there's stuff like RLlib and SP3, and like Gym and Gymnasium with their vectorization and wrappers and things. Everything was bloated and slow, and you just had to like cut off all the fat, and it just took forever. But we got to a point eventually where stuff is just good now. For me, I've been working in RL since, well, I started Neural MMO, I believe, in 2018, maybe? 2017 or 2018. That's when I started doing RL. Okay, why is the observation out of bounds here? Three. This change. 1, 2, 9, 13. How's this stuff out of bounds? What did I mess up here? Says 31. 20. Not. RLlib kills me. I don't want. Yeah. The thing is, the devs actually really tried hard with that, and like I know some of them. It's just I got a message, I think, like from a random engineer not realizing like all the stuff I've done trying to hire me for like RLlib. I don't it's like it's just not how you build for RL. You don't build a super heavy Fang style product for a field where everything is cursed and breaks constantly. You build the simplest, most compact possible thing, the smallest number of moving parts. That's how you build it. I've tried to help him a few different times as well, but I don't know. What the heck did I break? What did I break here, man? It's simple. It's very simple. What did I break? Welcome, Jai. Hey, Typhlosion. Welcome. Luck on runs. We have one cool experiment. So this is a couple cool things. This is 2048. It looks like we've gotten some solves out of this. And we also have a pretty promising neural MMO run over here. Very promising, actually. So this is the current one. And then this is the soda from before. So this is the run that I wrote my article about, and this is the new run. So basically, if it gets the same sort of curvature, which it looks like it might start to be getting, then it should be state of the art. We'll see. Yeah, all with Muon. If anybody wants to figure out how PSGD, like how to set up PSGD and have it actually work, I'm open to trying other stuff as well. Like I can set up a big run like this, but basically you'd have to actually set it up so it's not going to just crash instantly. We don't want to do this. This is 100. Something very odd is happening that this is out of bounds then, right? Should not be out of bounds. Oh, plus task. Hello, study. Welcome. Oh wait, this is out of bounds. I'm dumb. Yeah, I have been off by 1. That's all it is. Started ML like 1 month ago. Welcome to the space. There's lots of cool stuff you can do in here. Not good with the basics? I have references for new ML people that I always suggest. CS231N is probably the best, like, one-stop shop overall deep learning reference. The lectures with either Karpathy or Justin Johnson, either of those are good. Do you think I should go further? It really depends on your level of background, and especially like how good of a programmer you are, how's your math, what areas are interesting to you, like what do you want to do, right? I have my quick start guide for RL on the website puffer.ai. It's also on X. Okay, so if this works, this is orbit. Super cool you live stream this. I wish more people did. Yeah, it's been fun. I like live streaming all the work. It's been great for the project as well. We've had like several people from the live stream come and just say, "Hey, I want to start building some stuff," and many have been very successful at it even without AI experience. Thinking of being a quant analyst. I don't think they even do any like super crazy. I don't think they even really do any crazy stuff with ML. I think a lot of it's like pretty basic models that they use. And it's a lot more just about getting data that other people don't have. Where's the implementation of trajectory segment filtering? Yes, it's included. Here. So if you look at PuffRL, this is where all the code is, right? So you can see here. Hang on. Right here. You can see that we're not just iterating over the batch, right? We're actually sampling, and we're sampling based on these prio probs. This is prioritized experience replay using the advantage function as the metric. So it throws away low advantage segments. Low or high, I believe it is. Like, it throws away like things that are uninformative, basically. Low absolute value. It's all included. Can you help me to understand what project you're doing right now? I'm kind of in the middle of a couple different things, but pretty much we have this drone sim. I guess I can show this one. This one's a lot, like, this one's in a good spot. So this is a drone, it flies through rings. This is a sim. I'm building a sim in which you have a whole bunch of drones, and you can kind of command them to do different things. And then we're going to reinforcement learn the drones to be able to do that. Doing it for full... No, it's over trajectory segments. It's segments of length of BPTT horizon. That's how we do that. Okay, so we pretty much have the full sim, except for the fact that for some reason, I still have this math wrong on the circle somehow. Where did it go? Did I do this wrong? The radius of 8, pi times root of 5 minus 1. And then your sample, 1 minus x over the num agents, times 2 times the radius. Probably r is what happened. Just gonna guess that that's what I messed up. Huh. Yeah, why is this not... Why is this doing this? Can't understand what you're doing. I would suggest we have some good resources right here. If you check on puffer.ai, we have, there's this quick start guide. This gives you a lot of the basics of RL and a lot of the intuition for stuff. And also, some of these need to be reformatted at the top, but yeah. We also have the docs for this whole project and like tons of examples. So I'm building a simulator right now for essentially for a swarm of drones to behave in a certain way. And then I'm going to run reinforcement learning to make the drones actually learn to do that with Pufferlib. Apply each point. Okay. You build Puffer? Yes. Puffer is my main project. Okay, this could be it, technically. We need more drones to tell. There we go. That's a sphere. Yeah, that's a sphere, right? We're good. Let's do some basic thing first with this. See if we can get it to learn. What code editor am I using? NeoVim. Okay. Training is stable, so I guess I didn't horribly break everything in this latest change. See whether it does anything. This article really did very well. I only have one other article with 100,000 views, and it was kind of like a low effort baity article. So this is kind of nice to see actual technical article do this well. What do you do for a living? This. I do reinforcement learning work full time. Hey, Yannick. Thanks for the shout out. Appreciate it. If you missed it, I pushed a small change on GitHub to make it interactable. Articles going wild. Many views on Puff. Yeah, it's very good. Did you see the latest sweep that I did, Yannick? You will appreciate this for sure. So this is 600 million steps, and this is 2048. So we found some good parameters apparently. Neptune is so slow. They advertise it's like the fastest or whatever, but it's really not. Whole thing's frozen. Okay, well this worked. There you go, 3 minutes. So 3 minutes to solve 2048. So it looks like they don't all know exactly where they're supposed to go. It's pretty close. Interesting if it continues to solve. Based on the curves, it looks like it should. I will grab those hypers later and we can play around with it. I mean, or I could link, if you want to play around with it, I can link you this. Here, I put the sweep in the dev chat. See if that link works. Does each drone have its own target point? Now it does, yes. Okay, this should make it substantially easier to learn. Got 470 before. Yeah, we can push the env. I think it's a quite good environment, actually. There really aren't that many things that take that many steps to learn, like on the game environments. And the episodes are not like crazy long either. It's a good environment. Thank you for the contribution. X improvement. Yeah, this is what we've sort of seen with a lot of my work, right? Sweeps are kind of just ridiculously overpowered. Oh yeah, this is also with a simpler and smaller model than the one that you used. So, it's pretty crazy. This got 470 before, did it not? Hang on, let me go get the... I closed the tab because Neptune was crashing stuff. It's very similar. So I guess we'll see whether this helps it stay stable and keep learning or not. All I did was, this experiment is I relativized the observations. Actually, you know what I should do? Every time I think of a thing that's like a basic trick that I want to talk about, I'm going to just put it into the bottom as a note. Relativizing. That'll make the article way better. Okay, so this looks maybe a little better. Still kind of crashing a bit, though. It still ended up better, right? Yeah, it still ended up a little tiny bit better. I guess what you would expect. Here's Drone Sphere. Okay, so next what we can do, we train them for all the tasks simultaneously. That means I get to delete 4 dimensions from the ob space. So that is 20. Wait, am I stupid? 27. Yeah? Where I cannot add 7. Okay. Now, we rebuild this and we see if we can do all 4 tasks simultaneously. So this is actually a fair bit easier because you really don't even need to know what task you're doing in order to do this. You just need to know where the target is. But let it be known that we actually had a version of this working pretty well, even without that. So like task conditional RL kind of just works, which is crazy because that's not a thing at all that used to work. Actually, if task conditional RL works now, yeah, there's some crazy demos we can throw together from that. I have the score normalized such that, or the perf normalized especially such that I think 1 is ideal, like it's working perfectly, but I don't think you can actually get 1. So hopefully this should be like reasonably good behavior. Okay, so this is orbit, yeah. Idle. Follow. Oh yeah, this is working. And they're trying not to crash as well. Well, obviously we have to fix the drone trails and stuff. Like 20 as well. Way better. And we'll fix this. Actually, we'll do this next. We'll just fix this next. And then we'll add in the rest of the tasks. And then we will be pretty well set. Like, we'll have an awesome drone sim that works with RL in like a day and a half of like pretty lazy work. Alright. I'll be right back. I forgot my daily deadlift. Okay. Back to Vuk. Let's do... We'll do the 2-component reward, in fact. All sore today, and I don't know why. A bunch of pull-ups and like some curls yesterday. Do anything else? Weird, man. Oh, I guess then this does get updated, huh? Yeah, you can do... When I'm assessing a new area of work, I always look for wrong fundamental assumptions. So I thought Puffer will win. Pretty much what we do. I mean, I kind of have a probably not as great of an outlook on it in how I get to that conclusion, which is like, I kind of assume everything is done in the stupidest and most incompetent way possible until proven otherwise. And like when I see a few things done incompetently, I look for other things done incompetently. This is solid. Okay, we do actually need this stuff as well, but it can go into compute board. Episode return. Okay, episode length. 4. Get abs reward for this. Yeah? Now the only thing I have to do besides this, making sure that I didn't mess anything else up. Collision reward, target reward, and that's it. I could do the absolute reward. I may as well let it see the... May as well let it see, right? Let there be light. Now 28 numbers. Definitely better. reward like this. And we also wanted to fix the trails, right? A little awkward. You can probably do something like maybe I can do something like this. Not quite. Really? I would think that this would do it. No? Oh, hang on. I think is it just indexed wrong somehow? This is it here, isn't it? Thought this would be it. Really good references in your quick start blog. Thank you. I am working on another one. I've started on like another educational article. It's going to be much longer. And it's going to take me quite a bit of work. I'm just kind of doing it bit by bit, but I'm working on that. Costa is. I think Costa's like the only other person in RL where I'd like. I have literally nothing negative to say about Costa at all. Costa's just awesome. Like, it's one of these things where I don't think the field realizes how screwed reinforcement learning would be without Costa. Like, including all the stuff I do. Like, we would just be beyond screwed. How could this happen? The heck is going on with this thing? It's that it follows the drone. Count to 0. Really? For 1 frame. Why does this guy have both trails and this other one doesn't have any? Oh, this needs to be 0. Now they both get trails. That was stupid, right? Thing. When it's out of bounds, you reset the agent and terminals is set to 1. Okay. And then you call render. Doesn't draw the trail. Very weird that this thing does this. How does the trail jump on reset like this? It's like the frame after they reset or whatever, right? Okay, so this is just not doing anything, I guess. Oh. You are stupid is why. Actually, shouldn't it just be... just this? Okay, they still zap though, like this. Why they zap? Okay, so this is still... Still doing this weird zappy thing. Is 0. Okay, so this is getting called. Very silly bug to get stuck on for this long. Is it just drawing it somewhere else and I'm just dumb? No. This is where it's drawing it. Very odd. Okay, this is the expected behavior. Okay, so you can actually see that it is wrapping around and screwing it up. This terminated condition does work. The heck is wrong? Hello, your potato. This is live reinforcement learning dev. I'm currently working on a drone simulator. I can show you a different version. Okay, apparently I don't have it. I can show you this version at least. So we have a couple different drone simulators, and I'm currently working on a version that has a ton of different drones that can like fly in a sphere or hover or like do a few different things. And we're training them with reinforcement learning. That is currently what is going on. You can watch some of these live in your browser at puffer.ai. You have all sorts of games and simulators and other things. This is a trained agent playing it in your browser. This is a trained agent that plays in your browser. We have lots of different things in here. I'm currently just trying to figure out why these trails on these drones are not rendering correctly. I'm stuck on a very basic thing at the moment. Yeah, see it like it zaps and like follows them for some reason. Like an off by one or some weird thing. I honestly don't know why this is doing this. We can just redo how the trail works a little. So you get the position. Oh, I see. That wasn't it, but hang on. It's something like this. See what their original indexing was? I forgot how the indexing was done originally. Probably just in plus I minus 1. How does this make sense? Increment the trail length. Oh, I see. Yeah, this wasn't designed to be used this way. Okay, so we have to redesign a little bit. Are variables ever different? No, they're not, right? Well, they are in the sense that, I see. No, the original is actually correct. Do like this, increments up to this cap. And it should be that you count backwards. So, but instead of subtracting j, okay, so the intensity is backwards. Somehow this breaks it. Just off by 1 now, I believe. Think how we do this? Back j. I hate when I get stuck on silly things like this. It's just, like, it needs to be done, but I'm stuck for some dumb reason. Like, incredibly, incredibly basic as well. Literally just a ring buffer. This is really the simplest way to do it as well, isn't it? Hey man, I'm not from a coding background. Should I learn coding? I mean, if you want to, right? I don't know, it's your life, man. What the heck? I'm sure I just have the modulo arithmetic screwed up in some dumb way. I'm 19, all this looks too flashy. If you want to see some cool demos, there's some stuff on puffer.ai. Some of the agents that we've got. Thank you for the reminder for folks, Linky. Do star the puffer. It's all open source code. It's on GitHub. Find the link at puffer.ai. Star the repo. Helps us out a lot. Give up. I'm gonna just debug it like this. Yeah. How are we seg faulting? Wait, what? Okay. I got silence for dropping a link. I don't have anything on that does that. It just does it automatically. Oh, this is weird. Yeah, these numbers are way too big, aren't they? Oh. Okay, it was literally an off by 1. That was annoying, but whatever, we got it. Okay. We are ready. Train a model on this. See how this looks. We'll add the new rewards in. Should be able to have this cleaned up for today. Train this now. See how this goes. The article got more than twice as many views as the release that literally rewrites reinforcement learning. Crazy. Love the new video today. Oh, the trailer that I put online? Yeah, I realized that I hadn't put our release trailer from X onto YouTube. So I uploaded it as a I uploaded the 1080p one, and then I also uploaded the shorts one. Oh, that's hilarious. Community note, not an operating system. Don't underestimate the power of shorts. Yeah, I've uploaded a few small things and they do well. It's funny. Oh, hey, Erin. Yes, now I remember. Comp chem and things. I saw it naturally in YouTube Reels. That's the algorithm. Okay, so can we do eval? Have it look decent now. Oh yeah, look at that. Following this ball now. Required me to create a channel. My friend, I'm preparing a review paper on machine learning force fields. Very cool. as you can see on the channel, I don't really post a ton of like videos. They're a ton of work. I have like 400 something live streams though on the channel so far, and I mean I write articles. I post those on X. Fighting, start discussing a lot of RL and chemistry. Absolutely. You account for the turbulence caused by other drones in the area. No, that should be accounted for by just telling them not to slam into each other or get too close. What RL methods are the drones using currently? It's the main trainer and pufferlip, which is not exactly PPO. It's quite a bit better, but it's based on it. Oops. 1 second, folks. Be right back. Okay. Add the task for them to form a line, I guess. 1 plus target. Ah, I see. So I do need to figure this last thing out, which is I need to figure out a separate way to set the target and then move the target, I guess. Here's this. That. Okay, so this is random position. Target idle. Target. Target hover. Okay, so this works. This is just going to be set target orbit. Target follow. Go to the first agent or whatever. Dinner soon. Going to end finish first. Set the target and align. Update function. The only ones that need update, we have idle, follow. What are you fixing now? I'm just adding a bunch of tasks. The goal is you're gonna have like a whole bunch of different tasks that the drones can do, and now, or like commands they can follow, and I'm adding that in. Don't need this. What was your school experience like? What were the biggest rewards and takeaways? Like undergrad or PhD or everything? I'm pretty negative for the most part, overall on like traditional coursework to learn stuff. I guess it's more like the vast majority of the courses are not well taught. Some are. The ones that are good are very good, but the majority are just kind of a waste of time. For PhD, it's not really school in the same way, at least not in CS. Like you take a total of 4 courses that aren't really relevant or helpful in any way to what you're doing. There really isn't coursework that you can do that's going to be relevant to the research. It's kind of just up to you to like teach yourself and figure it out. A couple of the intro courses in undergrad were good. I had one really good ML course. I had like a couple decent miscellaneous other ones. And other than that, I mean, I spent like half of my time in undergrad just doing research. Like, I was pretty much doing full-time AI research starting sophomore year. A little earlier. A little earlier, actually. Think if there's anything else like super interesting. Takeaways. A lot of the stuff has just been you need to spend a ludicrous amount of time learning the thing and like use the materials that are good to learn, but very often it's just going to be you have to figure stuff out and it's going to be slow and it's going to be a grind because there just isn't material out there that you can use to like be taught it. Basically, you have to learn it yourself. I mean, it literally took me like, I think it took me well over 1,000 hours to figure out the basics of neural nets because there were just zero good resources back then at all. That was even a little before undergrad, to be fair. But yeah, like when I took the main Stanford ML course, it was completely irrelevant, and it didn't even touch on neural nets at all. I don't think if there's anything else. I don't know. If you have other specifics, I can answer stuff. Learning takes time. Well, it's like a lot of the coursework isn't even going to help you. Like, take RL specifically. You can go take an RL course and understand everything perfectly and get 100 in the course and have absolutely no idea what you're doing. Like, I literally have people that spend a few days going through some of the stuff that I've done, and they have a better understanding than if you go read the entire Sutton and Bardo book. I don't know, like, academia has a way of teaching stuff and a language by which they teach stuff. They kind of just like to beat you over the head with math until you, like, get bored and stop, I guess. But, like, they'll do it even if it has no practical application or it's, like, not even fully correct. They'll just do it anyways. I don't know, this has been one of the things I've been pretty good at, right? Is, like, identifying gaps in the way that things are done and then just doing it a completely different way. I got into my CS Masters from Chem, and I have gaps in math. Only fill them after I finish grad. I'm trying to do it along courses and research is too much. Honestly, most of the math in RL is like wrong. Most of the RL math is just wrong. There are very small bits of math that actually matter. Like, the whole basis of a lot of stuff, it's like all derived from tabular Q learning on MDPs, and it's just a mess. Please mention what needs to be changed. I'm working on an article that will cover a lot of it. It's mainly like they do 10 times too much math and 10 times too little engineering. Like, they don't care about solving the problem. They care about doing a bunch of math. It's weird. Like, they care about writing fancy algorithms and, like, running their experiments and, like, saying A better than B, even though statistically it makes no sense. It's like, there's, like, a very cookie-cutter way that stuff is done. And that worked up to a point. And then when it was time to actually, like, make all this stuff fast enough so that that approach could continue to be useful, everybody kind of just threw up their hands, didn't do it, and let the field die. I'm not even remotely exaggerating. RL is a field where understanding a little bit about the history of like how stuff has developed over the last few years will do you a lot more good than like understanding 20 algorithms. This is a generic question. I'm a third-year undergrad, and ideally want to be some kind of ML researcher or applied scientist. Pretty comfortable with understanding the latest developments in LMs and diffusion-based models. Okay, that's a lot of math, so you're probably set there, minus RL. If you were me, what would you focus on right now? I don't know what I should do to achieve my goals. Research engineer or applied scientist. Yeah, so research engineer is a little bit trickier because it's usually like they kind of just grab people out of masters or whatever. For ML research, and then also qualifies you for research engineer positions. Doing a bit of your own research is probably good. Publishing something is probably good. So getting to the point that you can function autonomously like that is good. And then on the engineering side, just like if you want to go that route, then just do the exact same thing, but do it with an engineering heavy approach, right? Like focus on doing stuff that is engineering intensive and also produces a cool result that you can publish instead of like the traditional one, which is the traditional science thing where like scientists can't write code at all. I don't know. That's the vague general advice I have today. Appreciate it a lot. Yeah. You can look at like my RL specific thing. There's a quick start guide on puffer.ai. It has a lot of good reference material. I mean, my path was pretty much that I started research really early on. I didn't really have a specific topic of interest, so I started doing some natural language processing because that was the lab that was there. And then I went and I did some computer vision. I managed to publish one thing in natural language processing, put a couple just archive manuscripts out on vision stuff. And then I came up with the idea for Neural MMO, and I learned the RL and all the stuff around it to make that happen. I did that for my whole PhD, and then in the last year and a half, I started doing Puffer. And the goal here is to use all the knowledge I gained about RL to make RL a faster, saner, more stable field, because I saw that as a gap. a lot of science is a lot more cookie cutter than the path that I've taken. The path that I've taken is like the very high variance path, where you're kind of just going to get stomped a lot of the time because researchers don't like it when you do work this way. But you're also going to be able to solve problems that nobody else can even. So that's what I can speak to. It's all very impressive. Oh, thank you. It's most of what I do, so I would hope it is. Hey, what's going on? Can I get a quick overview? This is Reinforcement Learning Dev. I stream all of my research. I'm currently working on a drone environment where you can send commands to make drones go in, arrange themselves in a variety of patterns, and follow each other and do stuff like that. If you want to check out some cool demos, they're all on puffer.ai. You have agents that play games and like do other fun stuff all in your browser. Any advice on YouTube versus Twitch streaming? Free automation tool. I stream on both. I just do it through Restream. And I don't know what you mean for free automation tools specifically. Okay, so Congo. How to make the posts get automated. Message everything externally. What do you mean how to make the posts get automated? Like, posts get automated. It just like YouTube just shows up. YouTube will just record your VODs automatically for you. You don't have to do anything. Twitch will record them, but it won't store them forever. That's just Twitch being Twitch. Nothing you do about that. YouTube is really going to be your main archive. X will store. I don't know how many. I think X has a cap, but it'll store the last many. X automatically posts your stream when you stream. YouTube, it automatically shows up in the live tab and it gets recommended to people. Same for Twitch. You really don't need any like extra tools. You do need something like Restream to make it a little easier to stream simultaneously to many services. Oh yeah, this is going to be really good. Thanks a lot. How would you learn RL? Teach RL to beginner researchers. I'm making another one of these, but the quick start guide on my website is very good. Like that's literally it. Do that, start building environments. If you already know how to program, you can literally start doing RL over a weekend. If you don't know how to program well, then that's the hard part, right? We'll add one more task. What are you working on here? Here. So you can see that there are all sorts of different configurations. Some are stationary, some are mobile. And I'm defining a bunch of these, and I'm going to reinforcement learn these drones such that they can do any of those patterns. They can arrange themselves in any of those patterns. Yeah, almost done as well. Do here. Almost quite. Okay, so almost. Can make it better later. I want to at least get it to run. What's your recommended way of understanding a given environment? You know, init step and a reset function. Oh, understanding like one of the puffer environments? You can mostly read it from top to bottom. Like these are like, except for some of the messier ones, they're mostly written in as simple as possible basic C. So like, go watch it. If it's playable, play it a little bit. If it's playable, play it a little bit. That helps a lot. Still not arranged correctly. Try this. Yeah, mostly it's like playing the environment. The way you design rewards is less even to do. There are a couple RL specific things you need to know. But like the biggest thing, honestly, is just knowing what information the agent needs to solve the task and like what signal makes sense to actually tell you how to solve the task. It's like not even RL specific, right? It's just like basic first principles reasoning. Do wrong here. It's x divided by 8, and 8 divided by 0 to 7. From the ML side, where is the observation space, action space, and reward stuff? So the actual shape of it is in the Python file. And that gets passed in as just a pointer. So you just have a pointer to the observations. And then usually most ends have like a compute observation function, or it'll be inlined inside of the step function. And then reward, similarly, there's either going to be a function or it'll be inlined in the step function. Okay, I think this is correct. Good. Let's see if this thing learns. Rotor color. Okay, so this is now trained on, I believe, 7 or 8 tasks. See? 7 tasks. One of them is just it's like an idle task. One of them is to hover in place. One of them is to be in this like spherical orbit thing. There's a follow task where you have to follow a single target. There's a line task where they all have to put themselves into a line. Congo task where they got to follow each other. There's a plane task. Should be able to do some stuff with this. And that's a decent policy in like literally 30 seconds as well. It'll get better, but this is a very good start, I would say. This looks very fun. How do I get involved? It's all open source. Puffer.ai. Wait till you see this result as soon as this thing is trained. These are all the M's. Most of these are made by contributors. Some of them are made by me. There is documentation on how to get started. We suggest that most new contributors start by going through the quick start guide on the blog here. And then you're going to want to write an environment. Typically, like, you look for something that's fun that you can do in maybe a few hundred lines of code, not a massive project. People have come up with all sorts of stuff. We like things that are interesting, like interesting challenges for RL in a new way. We also like things that are just cool and interesting. Like here, Tetris ended up being really cool to watch. Just Tetris, but like look how cool it is to watch the AI play it. Like mesmerizing, right? We had somebody submit 2048, and completely counterintuitively, this ended up being actually a very useful environment for research. Because it turns out it's actually kind of hard. There are tons of things in here. Wait. I don't know what that is. Type of Polish dance? What? It's a sick, happy I stumbled across you. Thank you. Here, let me show you this thing real quick. Because we just trained this model. Okay, so if I hold tab, this will show you the target objectives. They do a pretty decent job of going to these targets. And if we sort of change up the tasks, so this is just a do whatever task, don't collide. We've got a hover task, which is stay in place, orbit, follow the single dot. We've got this line task. Okay. Arrange themselves in a line. We've got this Congo task. I need to make it so it doesn't reset so frequently so you can actually see. They are doing a Congo, though. You can kind of see it. It could be a little better, but not bad for a first result. Plain. That was quick. Yeah, so this is the thing with Puffer, right? It's literally 1,000 times faster than everything else that is out there in reinforcement learning. You can literally train superhuman models in seconds. Like this Pong agent here. You know how long it takes to train this Pong agent? Okay, so this is something that would take like hours or days before Pufferlib. This is how long it takes to train Pong. Okay, it's done. And if I will have to convince you, there you go. There's your agent that plays Pong. You're the blue one, obviously. So yeah, this is what I do all day. This is all open source. We do our own RL research on the algorithms. We do our own crazy infrastructure to make everything fast. We write tons of environments for use in research and applications. Yeah, this is the main thing. What did you optimize so well? We tore out and rewrote the whole stack. The result is actually pretty concise. Like, our code is actually a lot simpler than the other things out there as well, even though it's this fast. But the environments are in C. Very simple C, but it's C. They write observations directly into shared memory. So, like, you can have thousands of environments and all the data is immediately available on the main process without redundant copies. Trainers optimize for super large batches, which is not usual. We optimize the heck out of a lot of the overhead on the trainer as well. We made some fundamental algorithm improvements that let you do that more effectively. It's a mix of a lot of things. I think this is the first environment that I did in Pure C, is this snake environment. It's maybe 300 lines-ish of code. Very, very simple environment, but cool. Each snake is an agent. What batch sizes are we talking about? So I think our most common training setting at this point is 8192 environments or agents. So if you have a multi-agent environment, you count total number of agents. 8192 agents and a batch size of about 500,000. And our biggest experiments, if you haven't seen this article, this is a pretty cool article. So this one here, we did RL on a petabyte of data. So it was 640 billion steps, or 640 billion observations. And this one used a batch size of 3 million. You deploy a neural net for each trained agent. What's the data format of the policy when you save it? It is the same neural network executed independently. So they're not the same agent. They are completely independent of each other, but they share the same logic. That is our standard setting. And my PhD is in multi-agent RL. There are a lot of other things you can do. Some of them make sense, but mostly it's kind of best to just do it this way. For this. Not log in this. Oh, yes, score. Probably needs to be swept. Batch size 3 million, I'm going to go read up. Yeah, we have some pretty cool stuff. I think the best agent, very nice work, King Puffer. Thank you. The best agent that we have is the, so the 1 petabyte agent is available on the website. It plays Neural MMO 3. Takes a second to load in, because now it's loading a neural net and stuff. So this is a big game. Oops. I think I hit escape by mistake. Escape is mapped to undo. Hang on. Did we break it? When does tab break it? Oh, that's obnoxious. You should be able to zoom out on the map. I didn't even push an update to this thing recently. Well, apparently I can't zoom out to show you how big the map is, but the trailer for that is on X. Actually, you know what? No, I totally can. Because I have it locally. Neural MMO policy is only 3 million parameters. Alright, this is the map. It's not actually fractal, but I left it this way because we do actually train on multiple maps at the same time, so it makes sense. So it's like this big MMO. And if you watch the agent, you'll see that it's capable of using tools. It gets equipment. It knows how to put stuff on. It knows how to fight. It knows how to kite enemies. Sometimes it even knows how to sell and buy items on this marketplace. Like a 3.4 million parameter-ish network. This is our best agent, I would say. I wrote an article about this. I subjectively consider this result to be better than emergent tool use and capture the flag, but nowhere near as good as something like AlphaStar and Dota. Based on my own subjective opinion, so deal with it. Option space there is huge. In Neural MMO, yeah, you'd think so, but guess what? I have the action space mapped to something like a discrete of 26. That's part of env design. There are some tricks that we have. It's a bit wry. I mean, I'd hope it's cool. Neural MMO was the topic of my entire PhD and 2 years worth of research before that. So I'd hope it's cool. Yeah, thank you. We're not done with it either. I literally have I have an experiment going right now. It's doing another 1 petabyte experiment at the moment. This is approximately 350 terabytes. No, wait, is it 350? Yeah, 350 terabytes into training. And currently it is doing pretty dang well. Can you say what hardware you're running this on? You see right behind me? You see the white boxes up on the shelves? Those are tiny boxes. There's 6 GPUs apiece, 6 4090s, and we ran these experiments. Just need one of those boxes to run an experiment like this for maybe 3 days, 3 to 4 days. You don't need a crazy amount of hardware. You need a little bit of hardware, not a crazy amount. This is the only thing in Puffer that requires a multi-GPU machine as well. Nothing else requires multi-GPU. Everything else you can train at home on like a single 4090. 3080 or whatever, if you have one, it'll just take long, right? You're never going to be out of memory for the most part. Okay, let me get this stuff configured. I gotta go to dinner soon-ish. And I want to make sure that we get a sweep going on this. Read up on the details. This is awesome. Thanks. Hey, I hope you enjoy. We're always looking for new contributors. So if you want to get involved with research, be very happy for the help. Yep. Stream every day. I do not stream 7 days a week. I do occasionally rest. I mostly stream at the moment on reasonable hours Eastern time, subject to other meetings and stuff that I have to take. So most of the day EST, sometimes in the evenings, depends how I'm feeling. Sometimes I work late as well. Usually stream like Monday through Saturday. Now the thing is, I am going in like a week. I'm going to Palo Alto, so I'll be on Pacific for a bit, and I'll probably be having a lot of like business meetings to deal with, because that's the point of being there, right by SF. All sorts of meetings. Then I'm going to RLC, so I will be at RLC in person for presenting Pufferlib. Pufferlib 2.0, which is old at this point, but that's the paper that got accepted. And then I'll be back in Palo Alto for a few weeks, and then I'll be back here for quite a while. Oh, it's not super consistent when, but the number of hours is quite consistent. If that makes sense. Congrats on all the W's. Thank you. Well, we could still use some larger contracts, right? We have a slightly profitable private RL lab. Ideally, we could have a very profitable private RL lab, and then we can fund way more research. That is the ideal. Make that happen for sure. I hope so as well. I think we should be good. I pretty much just need to be spending a decent chunk of time looking for good applications where we can really solve people's problems with RL. Sort of been doing that passively over the last weeks since the release. Find a couple of those and we should do that. And get back to doing more research. UK. Okay, so this works, yeah. Have you looked at chip optimization with RL? Planning to give that a go soon. It's a much harder problem because it's a placement problem. You kind of just have to zero-shot output the entire chip. We do have some good RL stuff, so it's possible we could do something there. I've sort of thought about it. It's not anywhere near as easy of an application for initial entry point into industry. We actually almost got a client in that space quite a while ago, just on like the general RL tech that we were doing. Need a high-speed simulator is a big barrier. Yep. Are there workarounds that you could invent? Yes, there very much are, and that is the subject of quite a bit of research. I think we are better positioned than anybody else to do that research, but the thing is, like, we kind of already have a bunch of valuable tech, so my plan for the time being is to find useful areas where we can build fast simulators, make the company much more profitable doing a couple of those things, and then invest that to do the research to make RL work in other areas, right? That seems the most sensible course to me. Can we just appreciate that this thing is running at 4 million steps per second, by the way? Thing is running like an overnight, the equivalent of like an overnight experiment from my PhD every 2 seconds. All right, we'll leave this here. And then this will run us a nice Hyperparam sweep. You should be in good shape with that. What else do I want to do on this? I may as well just clean it up for a little bit right now before I have to head for dinner. I'm gonna head out just a little bit early, I think, as well. My family is visiting; they just got here. But let me real quick. I just want to rename it real quick. Yay, yay. I'm back. How much of the drone code have you written by yourself? How much of it is off the shelf? Such a huge space. We have two undergrads who are helping with the drone stuff. They wrote, I will show you their sim. None of it's off the shelf, though, that's for sure. So Finn and Sam, who are in the Discord, wrote this. I helped a little bit with some of the learning, but they wrote this. Trained with Pufferlib. And then in the last like day and a half, I modified this. I made a version of it that supports a bunch of drones. And then instead of having ring targets, I have a configuration that's essentially just like tells the drone to follow an instruction. There's Finn. Finn's one of the authors of this. You'll see, Larry, that like a lot of the stuff in Pufferlib, it's like these crazy things, but it ends up just being a few hundred lines of code with the way we build everything. Like, the more complicated stuff ends up being a few thousand lines of code. But I think all of Neural MMO 3, this whole project here is under 3,000 lines. No, it's the exact opposite. None of it is abstracted. That's why it's short. This is why you see me writing like almost no dependencies C. Oh, whoops. Environments in C. I have some practice to do. I'm a physics grad. Oh, yeah, perfect. You'll be well positioned then. That's actually super useful because that's like one of the things I'm very bad at, and I love having people around who are good at that. We keep the C really simple though, like really, really simple. We actually have brand new programmers who have gotten into Pufferlib and have been just fine. Like, this is the entire source code right here, is this 800-line file. And I'm actually embarrassed that this is 800 lines. Like, it should not be 800 lines. So I'll have to go figure out what the heck redundant stuff I have in here. Okay, there we go. Still works. Commit this. Trying to solve a fiber optic pathfinding algorithm at the moment. Cool. The name of the game with RL is like as fast simulation as you possibly can for interactive processes, right? So if you have a problem that can be formulated as an interactive process, you can write a fast sim for it. RL is usually a good fit. There are a few exceptions. Stuff that relies a ton on like language is not great. Vision is better, but still not amazing. Mainly just because it makes the sim slow. But other than that, yeah, you can solve like a lot of really unintuitive problems really, really fast with this stuff. Do you think pathfinding could be an RL problem? You could turn it into one. Yeah, you could definitely turn it into one. I mean, we have well, it actually takes a second to train an agent to do our mazes. Let me see if I can find the graphic of our mazes. It was in one of the articles. We have the best maze solving RL agent that doesn't like hack it with other stuff. Yeah, so here's our maze solving agent. You kind of need to be familiar with RL stuff to know how impressive this is. This maze right here, like that tiny one, yeah, that's about as big as the mazes usually get in RL, and even that doesn't really work, and people like hack the algorithm to force it to work. So this is what we got just out of the box without really doing anything special, just running our algorithm. Combinatorial optimizations on graphs in the dev channel. You can definitely try it. Yeah, you can definitely try it. It's like kind of a decent approach for stuff where verifying the problem is really fast, but like can't even really get good data on the problem because generating the data is super slow. The heck is this? For GG Puffer. See? I'll check this and then I gotta run. Oh wait, in the VC do you mean or what? We have this weird case where some networks subsidized, like free to build, so some of the edges in the nodes are free. Limitations node limit, that's fun. I don't know who this is just chilling in the VC if that's what you meant. And I do have to run and I gotta run for dinner. Thing. Okay, so for the folks watching here, thank you for tuning in today. Probably won't be back after dinner. We'll see. My family is here. They're visiting. I will be back in the morning. So if you're interested in all this stuff, Puffer.ai for all the things. Lots of cool projects built by contributors here. If you want to help me out for free, literally free, in 5 seconds, just star the repo. Feed the puffer. It really helps. Like, actually starring the repo really helps. And other than that, yeah, join the Discord. You can follow me on X for more and all that. And I'll be back tomorrow. More reinforcement learning. See what I work on.